aqua, H2O, water. You know, that liquid we're supposed to drink every day and that's pretty widely regarded as critical for life here on planet Earth.
A whopping 70% of our planet is covered in the wet stuff, in our lakes, seas and oceans.
From the icy depths of the Arctic to the sun-drenched tropics, these bodies play a vital role in shaping and sustaining countless ecosystems.
But as our world warms and bodies of ice melt, our sea levels are creeping higher.
The rate of sea level rise is increasing.
Majority of the islands of our country will be uninhabitable.
When we get storms, we're going to get some pretty big ones.
We have some very difficult decisions to make.
So what will our Earth look like in the future? How will we adapt when coastlines are reshaped and livelihoods are threatened?
And how can we help our Earth defend us against these waves of change? From the Natural History Museum, this is Our Broken Planet, where we find out how we created some of the problems in our modern world and search for solutions from nature and science. I'm Tori Herridge.
And I'm Khalil Thurlaway. Across this series, we'll be exploring the interconnected problems facing our Earth. We'll be examining some of the issues that we as humans have created and asking the question, what can we do about it?
We're not going to sugarcoat things. The health of our environment is in a critical condition. Global warming presents profound threats to human lives and livelihoods, and we're seeing record losses of biodiversity as our world becomes less wild. But the future of our planet isn't set in stone. Decisions and actions we take today can have a massive impact for life on Earth tomorrow.
So throughout this series, we'll be taking you around the world to learn how we humans are affecting nature. And along the way, we'll be meeting some of the amazing people fighting to create change.
We'll also be learning about the science of what's happening and exploring the social, political and economic issues that are the source, but also maybe hold the solution to these problems.
And to kick us off for this first episode, today we'll be talking about our planet's rising sea levels. Now, sea levels are one of the aspects of climate change that probably get talked about the most. I guess because it's hard to ignore the sea getting higher.
Yeah.
You know, it's not in question.
Yeah, and also, I think it's like at the forefront of lots of people's minds because 40% of the world lives within 100 kilometres of the coast.
That's billions of people. And people rely on the seas for food, for transport, for all sorts of things, for livelihoods.
It's almost like the poster child of global warming. I think the first thing you think of is a polar bear on a melting iceberg, and you know where that water's going, don't you? It's going into the ocean, and if it's going into the ocean, the sea level is going to rise.
Most of the sea level rise we're seeing at the moment is coming from melting ice sheets. Now, ice sheets are these huge, great big plates of ice that hang out at the poles of the Earth, north and south. So let's go now to the Arctic and the world's largest island, Greenland.
Okay, so right now I am standing on sea ice. Underneath me is about a meter of ice, and then the ocean. We're all going to walk out to an iceberg, and this is just basic insanity.
Laura Tenenbaum is a climate expert and a former NASA scientist. That's her on the northern coastline of Greenland, well into the Arctic Circle. Greenland is a country which is mostly an ice sheet. In other words, a massive chunk of ice that sits on top of land. There's only two on Earth, one on Greenland in the north and one on Antarctica in the south.
When you fly over the ice sheet, it's like billowy pillows of white upon white upon white, every shade of white you could possibly imagine. When you're walking across the ice, it makes this very satisfying crunch, crunch noise because the air is so dry. The interior is a 2-mile deep ice sheet that has formed over the last, let's say, 100,000 years. And additionally, around the coastline, where you don't have the ice sheet, you have glaciers. It's rather beautiful.
Now, Laura wasn't just there on a sightseeing trip. Greenland is melting, more and more each year, something her and her team from NASA were trying to measure.
Most scientists understand that Greenland is being melted by the increased air temperature that's melting the ice sheet from above. It causes the surface of the ice to melt, and then you see these great lakes all over the surface of Greenland in the summer. The water kind of percolates like Swiss cheese through the ice sheet all the way to the bottom and flows out into the ocean. But as much as 90% of the heat from global warming is stored in the ocean. So the question is, how much is warmer ocean waters around the coastline of Greenland melting the ice from around? The hypothesis was that a glacier that sits in deeper water would be more exposed to that warm water and would melt faster than a glacier that sits in shallower water.
Their theory turned out to be true. The glaciers in deeper water are melting faster than those in shallower water. They also tried to map the seafloor underneath Greenland's ice sheet, something that had never been done before.
So think about where the bottom of the seafloor meets the glacial ice coming off of Greenland, meets the ocean water. So that's this interesting place that nobody had ever measured before. The other interesting thing, and maybe it's sad or horrifying or, amazing, is that the ice there is melting faster than we can even measure it.
So here's a mind-blowing statistic for you. In the last 10 years, scientists estimate that Greenland has lost on average 280 billion tons of ice per year.
I'm standing there in front of the ice sheet. It's like 200 meters high, and the water is just pouring off, right? I can just hear the water crashing. This ice is melting right in front of our eyes.
All right, Tori, let's take stock for a moment. There are 280 billion tons of ice lost from Greenland every year. Antarctica loses another 150 billion. So we've got well over 400 billion tons of ice lost each year from our ice sheets.
It's insane, isn't it? Stupid numbers. Numbers that are just so ridiculous. So, okay, putting it into numbers that we can all understand. Elephants. Come on, as an elephant paleontologist, it's always about the elephants.
You can always trust Tori to bring the elephants.
Let's face it, the only way to understand that volume of ice is to measure it in elephants. And let me tell you, that is more than 2,000 elephants stepping off into the ocean every second.
That is a surreal image.
The scary thing is that there's actually more melt each year at the moment than the previous one. So that rate is getting faster.
Since the beginning of the Industrial Revolution in the late 1800s, we've seen the ocean rise about 8 or 9 inches, which is 21 to 24 centimeters, which is bad. But even worse is the rate of sea level rise is increasing. So of those 8 or 9 inches, 3 inches has been in the last 20 years. And this is really bad news for people who live in low-lying areas on the coast.
So, as ice sheets melt, sea levels rise. Makes sense. But there's another factor to consider here as well.
There's 2 reasons that the sea level is rising. One is that we've got global ice mass loss. So that's ice from Greenland, ice from Antarctica, and ice from all the mountain glaciers on planet Earth. But in addition, what you have is called thermal expansion. Everybody knows this from your basic physics class. Warm air expands, warm water also expands. So we've heated up the surface layer of the ocean on planet Earth, and that warm water has expanded. About 30 to 40% of sea level rise is due to this thermal expansion, and the rest, 60 to 70%, is due to the ice that's melting off the land and falling into the ocean.
It's left some communities already struggling to fight off the sea.
There are islands in the South Pacific, like Tuvalu or the Maldives, that had nothing to do with burning fossil fuels. Those people are climate refugees. Of course, some people are like, who cares about Greenland? But we all need to care about Greenland because more than half of people on planet Earth live within a few kilometers of a coastline.
For most of the 20th century, we were looking at 1 to 2 millimeters per year of sea level rise, and that's doubled now to 3 to 4. And ice loss from the Greenland ice sheet In the 90s, it was 30 to 40 billion tonnes per year. And now we're looking at 280 billion.
Don't make me do that in elephants.
For the rest of the series, all
elephants.
maths done in elephants.
But it is big numbers. It's going to affect people from very, very far away from those centres of melt. Because, of course, the ocean is 70% of the world and it goes all over the place. It's like an obvious thing, like a blue planet. You heard Laura mention Tuvalu and the Maldives. I mean, these are island nations in the Pacific that are already seeing larger sea level rises than elsewhere. And another place like this is the Marshall Islands, which is between Hawaii and Australia. And it's there we'll visit next.
My childhood was always woken up with music on the radio that my grandfather would play at around 6 a.m. because he was an early riser. And then that was also accompanied by the sound of the waves crashing into the corals.
This is Selina Leem, a Marshallese climate activist. Around 70,000 Marshallese inhabit the 34 islands that make up the nation. Their ancestors have lived there for around 3,000 years, but this current generation are now fighting an existential threat.
We are in the front line of the climate crisis. Our country is 2 meters above sea level, and the waves, they're rising at 7 millimeters per year compared to the global average of 3+ millimeters per year. And so we face inundations every year. They're very frequent and they're very big for the size of our land.
Inundations are flooding events and can threaten infrastructure or endanger people's lives. Coastal inundations have been a constant threat throughout Selina's life.
It was actually my grandfather trying to get me to behave well. He would tell me stories of how the ice in both the North and South Pole would melt and soon flood our islands. And as a child, that terrified me. Whenever we would have floodings, I would think, is it me or are the waves bigger this year than they were last year? Sitting down with some of the elders in the neighborhood, the grandmothers would gather around and they would tell stories about how like the shoreline was further out into the water than where it is right now. It made me realize just how small our island was and then how terrifying the ocean can be. And we are completely at its mercy.
What's your first memory of an inundation?
The most prominent memory was when we were at our house and then it started flooding again, and my grandfather called to our grandmother and told her to go get one of the hotel rooms in the next town. I remember it was really dark and I started crying and I was livid because I kept imagining that my grandmother and my siblings and we were running away. We are leaving our grandfather behind. And if we come back the next day, I really felt like we were not going to see him again because I was imagining a really giant wave coming in. And so my grandmother had to literally drag me away from the house because I was like, I refuse to leave. I am going to, if grandpa is staying here, I'm staying here to protect the house with him too. Curse the waves if they're going to come and take him because I will be the one here to protect him.
Selina became a climate activist at 15 years old. At just 18, her country chose her to represent them internationally, and she flew out to Paris for the Global Climate Change Conference, COP21.
Olive. Greetings to you all. My name is Selina Leem, and I am a small island girl with big dreams from the island of Majuro in the Marshall Islands. I am only 18 years old, but for a long time I have felt nervous about my home.
Selina was the youngest person to give a speech that year and was part of the agreement to limit global warming to 1.5 degrees. 7 years on, while progress has been made worldwide, things look bleak for the Marshalls. Scientists predict that most of the islands will be uninhabitable within 10 years. But Selina hasn't given up hope.
I think there has always been optimism in this space, and the grit is always there. It's just so important to be connected to the people and the earth where you come from to remind you of why this work is so important.
Do you think the world is listening in terms of those big changes we need to make to slow sea level rise?
I mean, statistics are showing that a lot of people are actually concerned and are aware of the climate crisis, and they want to do something about it. But it's just the higher ups. They're the ones controlling the media. They're the ones controlling how negotiations are being done. And they're the ones controlling policy making and all these decisions. Their voice at times can overpower ours and make it seem like, oh, the world doesn't care. But the world does care because they see now what's happening in their backyard. And they are realizing, oh, wow, I actually do care about my planet. This is where I live. This is where my children and the generations afterwards are going to live. It's just the 1% that are being willfully ignorant and just drowning out the voice of the majority.
That optimism is an act of defiance. It is an active act of rebellion against a larger global system that is largely indifferent to her and her people's suffering and, impending homelessness.
Highlighting her final thought, though, there, right, she says it's just the 1% of people that are being willfully ignorant. She sees the world as actually on her side, mostly. It's just 1% of very powerful people that are the problem.
One thing that's clear is that a lot of the countries and communities that are being affected the most by sea level rise are not the ones who put out most of the carbon dioxide that's warming the planet, melting the ice, raising the seas.
No. And that goes hand in hand with all other kinds of unfairness and ridiculousness in terms of people getting stuff they just don't deserve. And another aspect of the Marshall Islands story that we need to examine around sea level rise links to that. To do this properly, we need to take a quick history lesson and rewind back to just after the Second World War.
3, 2, 1, 0.
We were used as a nuclear testing site by the United States government between 1948 to 1956, and they had tested a total of 67 nuclear bombs in our country. I believe Bikini is probably most well known because of the Castle Bravo bomb that the US had detonated on the island.
The Castle Bravo bomb, dropped on the island of Bikini, left neighbouring islands heavily exposed to radiation. The US say this was an accident, that they miscalculated wind direction and the strength of the bomb. Days later, the US sent scientists to the Marshall Islands to study the effects of radiation poisoning. Looking back, Selina feels they were treated like lab rats.
All the fallout flew to all the islands in the Marshall Islands, and people heard the thunder. They felt the earth shake. They saw the flash, and they just saw these mushroom clouds. And so they came outside, and they saw this white fallout, and a lot of them thought that it was snow. And so they started playing underneath it. They started eating it, and people obviously started getting sick immediately. The US soldiers, their team, were then taking our people to test the effect on their body.
Today, a remnant from all the nuclear tests sits on Runit Island, a 114-metre wide, 18-inch thick concrete dome, known locally as the Tomb.
It's literally this giant concrete just slapped into the middle of the island. And it was the US attempt to clean up the radiations on our island. It was not all of it, but the amount that they were able to gather, they put it into this dome. And there was a sign here that wrote, "Do not return for 25,000 years." And it's jarring to see because the island that this dome is on is just pristine, idyllic, beautiful blue waters, clear. You can see the bottom of it, just beautiful island paradise.
The Tomb contains tens of thousands of cubic metres of radioactive material. And to return to sea level rise, this dome is now under threat of being submerged.
This dome is leaking and it's eroding. So we're looking at this dome being under the water as well. And the rest of its contents, like really completely flowing out. This is one of many reasons why our people are so adamant to go out and make sure that our voices are heard.
This story makes me so angry, furious, because I do not believe the official US government line on this in the slightest. The US government has a long and filthy history of testing things on other populations, whether it's weapons, whether it's health things. It is sickening to see people, even if it was an accident, to treat an island that has people living on and nearby as a testing range for the biggest, nastiest weapon that we've ever made.
It's mental. Have you seen pictures of this dome?
No.
Okay, Google it, because it is ridiculous, right? You have this almost a stereotypical image of like a tropical paradise and then a concrete dome of death. No wonder they call it the tomb. It's just like an allegory of everything that is wrong about the world. Great big, massively polluting nation, massive military superpower decides to bomb a place which has got people living next door. I mean, it's just
I've just Googled picture of the tomb, and it's like something out of sci-fi.
Yeah, but it's real, Khalil.
Yeah, and that's the worst part. And a tomb normally contains dead things. This contains stuff that will kill you.
It's more just the intent, I think, to me. It is just so...
The complete disregard for people as people.
The oldest generation of that Marshall Islands, they would have grown up under the shadow of that happening. And then from that point onwards, you go from like radioactive fallout into continual and repeated and more frequent inundations of your land by the sea and a projection towards a future where things look incredibly bleak.
Death from above, death from below. Selina's story and the story of the Marshall Islands is a really, really stark example. But if we zoom out from there, there are so many other cities and communities that are at risk from coastal inundation and major flooding events. And scientists have been able to somewhat predict what cities will be most vulnerable and exposed by, for example, 2070. And some of the numbers of people and the range across the world of places that are going to be affected is staggering. So like Kolkata in India, you're going to have a predicted 14 million people exposed to this risk of flooding. A lot of places in South Asia, actually, Mumbai, Dhaka, Guangzhou in China, Ho Chi Minh in Vietnam, and all of these have double-digit millions of people who are going to be at risk of death or displacement from climate change-related flooding.
Coastal places are just, they're good places to live, right? Big flat areas, lots of people live there. You raise the sea level, lots of people get flooded.
Most of the top 10 cities on this table are in Asia. But number 9, you've got Miami in Florida. So it suddenly becomes scary when rich people get threatened. And New York is number 17. Remember, a couple of years ago, there was that flooding in New York, and suddenly the risk of flooding in rich countries became scary.
Well, you've got that number of people living in coastal situations, 40% of the world. But there are natural defences against coastal inundations. And the good news is that over millennia, nature has got pretty good at coping with sea level rise.
You feel like you're in a real sort of wilderness forest. You get the sound, water lapping, insects, bird song. The other sound you hear a lot is the constant clicking, and it's crabs. Thousands, millions of crabs in their burrows.
Dr. Mark Spalding is a senior marine scientist with the Nature Conservancy. He's telling me all about his area of expertise, mangroves.
Mangroves are trees that have adapted to grow in salt water. And they grow in the intertidal zone, between the mid-tide and the high tide, for the most part. And to do that, it's a really tough environment for any plant to live in, because it's sometimes dry, sometimes wet. About 70 different types of tree have adapted to grow in these systems. And they form forests.
But here's the real kicker. Mangroves are not just beautiful, wild, amazing places teeming with life. They're also a fantastic defence against sea level rise.
So let's think about mangroves as this narrow strip, really, between the sea and the land. And they form a sort of a barrier, a very permeable barrier, which the sea can get through. But nonetheless, think of this great tangle of trees and roots. They're in a really important place. And as the sea comes in, they tend to slow waves as they come through the seas. This barrier between sea and land protect us from storms and flooding and erosion. If you imagine a wave coming through anything, any kind of complex structure, it's very quickly diminished. It attenuates, we call it. And so you just need a few tens of meters of mangroves between a big storm and the land, and those waves don't make it to shore anymore. They're just completely flattened. Every year, thousands of lives are saved by the fact that people have mangroves between them and the storm. Another thing in the context of storms is that they basically block the movement of debris, and actually one of the biggest killers in storms, even in tsunamis, has been huge amounts of debris, and they all get tangled up in the mangroves as well. So there's just this kind of safety net and this barrier against waves, permeable barrier, but they really slow it down.
The big danger of sea level rise worldwide isn't just that the seas themselves are rising. It's that when they rise, the risk of inundation is so much higher. In some places, we've built walls to keep the sea out. But of course, that's very expensive and very difficult to do. But mangroves can do some of the job for us.
People have done work on the cost of building seawalls, and they're incredibly expensive to build. And if you can have a barrier of mangroves, you can reduce the height of the wall on the inland side because the waves aren't making it anymore. So actually, you can spend a lot less on building walls and still protect your coast.
Despite this, in the past 100 years, mangrove forests have been lost to humans. Urban growth and agriculture has eaten into their habitat. However, Mark is now seeing shoots of recovery as people's understanding of the value of mangroves change.
The good news is that mangrove loss has really dropped right off. We're almost stable now. Mangroves are very opportunistic as ecosystems. They're not this sort of delicate ecosystem that once it's gone, it's gone. They will come back if we give them half a chance. And they will also spread. I went kayaking through some mangroves in Mexico, in Baja California, and only afterwards I was reading a paper about a restoration site, and I thought, that looks familiar. And it had been restored about, I think, only 10 years earlier. For me, it was a mangrove wilderness, completely unchanged and so on, so it's pretty cool, actually, to see that.
That is really cool, to be so restored that it could fool you, somebody who knows their mangroves.
It's really heartening. I tend to think of mangroves as ecosystems of hope. We can get pretty gloomy about many things, rightly, but these are opportunistic systems. If we let them, they will be with us for millennia, thriving in our coastal areas and delivering many benefits to us.
Ecosystems of hope. That's what I like to hear.
No, it's good. It is good. They do sound amazing.
Right.
Like he was properly spirit lifting. So many cool things that we haven't even touched upon. He mentioned the fact that they can grow quickly. If you get it right, you can restore those mangrove areas pretty fast.
And if they're growing quickly, that means they're capturing carbon.
Yeah, and they're capturing it in that kind of like disgusting intertidal area, which is really stinky and murky. If you put your feet into it, it's like all smelly because nothing's rotting. So not only that, they're really capturing carbon, so they're super good carbon capture systems.
And I guess also because they're based on sediment, as the water level rises, they're going to rise with them, hopefully, if you let them.
Not in all scenarios, but in some scenarios, he actually says the rate at which they can capture sediment can keep pace or be faster than the estimated rate of sea level rise. So what is not to like?
Yeah, because that's one big difference between mangroves and coral reefs, because mangroves grow quickly, whereas corals, which also act as a break against sea damage, grow notoriously slowly.
Yeah, quite. And the thing is, like coral reefs, however, mangroves are limited as to where you find them. These are like tropical systems. You aren't going to get them in the northern hemisphere. They're not going to be a solution to the UK's
Guess
problems.
we'll see how many degrees we hit. Well, Tori, luckily, I've come equipped with a natural solution of my own. While you've been out in the tropics, I've been closer to home, in what scientists like Mark consider to be the cold water equivalent of mangrove forests.
Salt marshes form where the tides are able to deliver really fine sediment into areas.
Iris Moeller is a professor of geography from the University of Dublin. She's been studying salt marshes for decades.
So behind barrier islands, where you have islands that are really close to the shore, within estuaries, within embayments, you get this deposition of what we really call colloquially mud. Very gloopy, watery stuff that deposits there. But once that consolidates over a period of time, it raises the surface elevation of that sediment to a level where plants can come in and survive. When you start walking on them, your feet sink in. You get the kind of sound as your feet move through the mud. And you can hear water trickling around from the creeks.
Salt marshes surround the coastlines of countries with cooler seas, including the UK, Northern Europe, and North America. They might not be as naturally beautiful as the lush tropical vibes of mangrove forests.
Total interruption here. Disagree hard. Hard disagree. Beautiful. Salt marshes are beautiful.
Just bad lighting, I guess. But what they lack in what some might perceive to be conventional attractiveness, they make up for in practicality. They're super effective coastal defenders.
On account of climate change, we have projections that suggest that exceptionally high water levels might occur more frequently in the future. We are being protected from high water levels and from waves on account of the salt marshes being there, slowing the water down, slowing the waves down as they travel over them. And that, of course, means we experience less erosion on any areas that are landward of where a salt marsh exists, and we experience less flooding. And that's a really beneficial side effect of the salt marsh being there.
Like mangroves, salt marshes break waves, helping to prevent coastal inundations. And Iris would like to see more land given back to marshes.
We need to allow space for the salt marsh to move upwards and landwards to continue to exist to protect us. And that's often really difficult because to the landward side, we have often agricultural fields that are producing our food, and we need to protect them from salt water. So it becomes a difficult political decision to then decide to say we're actually going to allow the salt marsh to move further landwards and take out a sea defence that we built several centuries ago when we reclaimed that land for agriculture. We have some very difficult decisions to make here, whether we're thinking about how we farm, how we build our houses, how we develop our land, or how we develop our coasts.
I guess this goes to show that any solutions we come up with are going to have some kind of cost or trade-off attached.
We were talking about local solutions, to this kind of global problem. And I think salt marshes is exactly, I guess, a perfect example of that. And it's been one that's been dealt with locally for thousands of years, actually, in Northern Europe.
I think the one thing that has tied together all the stories that we've talked about today is that this is going to change everyone's lives. Whether that is the effects of sea level rise, getting rid of people's homes and endangering their lives, or whether it's the fact that we're going to need to change how we live to try and avert the worst of these changes. For example, you take the issue of immigration and refugee status, a massive issue at the moment. Sea level rise is going to be a massive contributor to people needing to move around the world. Because if your home disappears under the water, you've got to go somewhere. We're all going to have to acknowledge that people are going to have to move around because of this, and we're going to have to change our lives to avoid the worst of these changes and to accommodate people's needs in the wake of it.
Yeah, and I think also really wise to remember when we say people, that person could potentially be you.
And even if it's not, they're still people.
Thanks for listening to Our Broken Planet. We hope you've learned something along the way, and please don't despair. We all have an important role to play in helping to fix the problems in our world, and it starts with having conversations like the ones in this episode, as many as possible. If you found it helpful, why not share this episode with friends and family?
Let us know what you thought about this episode and join the conversation on social media using the hashtag OurBrokenPlanet, or check out the bonus content and resources over on nhm.ac.uk/podcast.
You can listen to our next episode right now, where we're exploring another consequence of our heating planet, the increasing incidence of fires around the world and what that means for us humans. We hope you'll join us.
Our Broken Planet is presented by Tori Herridge and me, Khalil Thurlaway. The assistant producer was John Rogers, the producer was James Tyndale, and the executive producer was Will Yates. Our Broken Planet is a Whistledown production for the Natural History Museum.